I'm Alistair Funge, Space Policy and Operations Engineer.
Hi, I'm Ran Kedar. I'm CEO of SpaceX Innovation.
Hi, I'm Dylan Taylor, Chairman and CEO of Voyager Space Holdings.
And I listen to the Cold Star Project.
And I'm listening to the Cold Star Project.
And I listen to the Cold Star Project.
Government money being awarded today was planned 5 years ago. The concepts of operations were developed 5 years ago. Sort of the initial mission concept reviews were done about 5 years ago. They worked their way through the pipeline and got down selected for topics for funding. That typically happens about 2 to 3 years out from when they want the work to actually start. Then they get awarded the year before they want the work to start, and then in that next fiscal year or hopefully in that same fiscal year, it kind of depends, that's when work begins. And if somebody just started their business yesterday and they think they're going to get a government contract, that's a hard pill to swallow, that you got to raise your sign much earlier than a month or 3 months ahead of when you want to be able to start working.
Welcome back to the Cold Star Project. I'm your host, Jason Kanigan, the founder of Cold Star Technologies. That's why it's called the Cold Star Project, because it is a project of ours. And I'm here with Tim Anderson. He has a couple of interesting roles. I met him recently. I like the way he thinks. We had a call, a pretty extensive call, and then I said, hey, you should be a guest on the show because you've got a lot of information and a perspective that would be very valuable to our listeners and viewers. So his main role is with a defense contractor, and I'll let you explain what that is. It's advanced programs for defense in space, which is really cool. And then he's also a Naval Reserve commander, so watch out. He can whip things into shape pretty quick. And so we're going to talk about two things today, mainly. There will be side topics because we both have this personality type that likes to connect the dots and see how this is connected to that and follow the breadcrumbs kind of thing. But the two main things will be Starship and what it means, what the implications of having that thing, that capability around happen to be, and also in his role with a medium-sized defense contractor, how companies of that size and smaller also can figure out how to get work, how to get contracts going. So thanks for being here, Tim.
Oh, thank you for having me. This is something I'm pretty excited about, so I think we're having a good time here today.
You bet. All right, Commander. Let's start off with that. Let me ask you about your Naval Reserve Commander role. Well, it's been like 9 years or so that you've been at this particular posting, and you've had a long career before that. So tell us about it.
Well, yeah. So I'm at about the 15, 16-year point of my career in total, and in my current role, which is operational level of war, yes, I've been doing that for close to 9 years now. So operational level of war is not the 10-year strategy, national security policy level, and it's not the face in the dirt, door kicking, riding on boats level. It's in between. Typically, a 3-star command is who hosts those functions. And the bulk of what I do is I fill what we call purple billets, so joint billets, in developing the campaign plans for how we're going to deal with whatever we're trying to achieve there for our national objectives. And so I will get in the room full of smart people and we will figure out how to peel the onion. And typically the first day, after we all kind of get to know each other and figure each other out, by the third day, everybody's kind of looking at me saying, okay, what are we going to do? Which is kind of an interesting role to have, especially when you're briefing the senior flag officers and telling them how we're going to get through all this.
Mm-hmm. Okay, and you are working on a master's degree at Embry-Riddle on Masters of Space Engineering. Tell us about that, because it's, we're not spring chickens, as we were just talking about before we started recording. Why would you do that?
So it's really interesting. I was finding that, while I had lots of experience in a lot of industries and tons of engineering background, it wasn't sort of packaged and certified nicely in a way that people could directly recognize. And so Embry-Riddle in particular is really great with veterans. I'd say about a third of my class, of every class I have, minimum is veterans. So that was really appealing for me. But, I'm basically going back through and polishing up a few things here and there and getting some credentialing behind close to 20 years of experience now total in working in various fields.
Right. And just so that people understand, you have the technical ability already. This is sort of, like you say, ticking some check boxes, and future employers and that kind of thing might be interested in. You've got, for example, 2 papers going in peer review right now for this year's IEEE Aero Conference. Tell us about those papers.
Yeah, so they just passed peer review. The results came back, the final results came back last night, and was very humbling to see so many positive reviews come back from those papers. So the topics are basically cislunar and primarily lunar surface architectures for the first paper, and how we deal with the concepts around basing and outposts and settlements, and how those things interact, and then the logistics involved with connecting those different destinations on the lunar surface and what that starts to look like. And then that tees up some conversations about mission requirements in terms of different people looking to accomplish things on the surface, whether it's science, taking measurements, doing observations, understanding the lunar environment better, or the hard rock drilling arena is something I'm really interested in learning a lot about right now. And they all have very different requirements, but there is some intersection there. So I did a market survey, and the results of that are part of the paper that offer some really interesting insights and show a kind of a very distinct divergence in the way people are thinking about operating on the moon, and especially in terms of landed mass, power requirements, and things like that. And that's part of what we'll get into here when we talk about Starship. And then the second paper really presents 2 designs for landers, and primarily hopper vehicles, which NASA's become pretty interested in, that service the mid, I call it mid, we'll get into the numbers later, but so, we're talking several metric tons to 20 metric tons range of payload capacity, which is distinctly different shift than what we're used to. Most of the competition, most people are competing right now in 500 to 100 kilogram payloads right now, the lunar surface, or hopping it around the lunar surface. It changes things a lot. So that's what the 2 papers are on, and I'm really excited. It's come together nicely.
Yeah, well, I look forward to digging into that later on. So let's see. You've got a note here. You're constantly working on this question, and the answer is always changing at least a little bit. How are we going to make money 5 years from now? So tell us about arriving at that question as sort of a main filter for what you do, what it means, what it implies, and then how you go about it. So
my master's program is really heavy in unmanned systems, and in part of my role with the Navy, I can flip hats, right? I can be Contractor Tim one day, and I can be Commander Anderson the next day. And in my same office, they are wrestling with some challenges concerning bringing unmanned systems to the fleet and taking on responsibilities for service sustainment, man training, and equip issues surrounded with unmanned systems. And so I offered to come in as Commander Anderson for a little bit and wrestle those things. And it really kind of crystallized what I see every day in my contractor job of how far out you have to be thinking about things when you're dealing with the government and government funding. And so, I think it's always important for people to recognize that government money being awarded today was planned 5 years ago. The concepts of operations were developed 5 years ago. Sort of the initial mission concept reviews were done about 5 years ago. They worked their way through the pipeline and got down selected for topics for funding. That typically happens about 2 to 3 years out from when they want the work to actually start. Then they get awarded the year before they want the work to start, and then in that next fiscal year or hopefully in that same fiscal year, it kind of depends, that's when work begins. And that's if somebody just started their business yesterday and they think they're going to get a government contract, that's a hard pill to swallow, that you got to raise your sign much earlier than than a month or 3 months ahead of when you want to be able to start working.
That is very interesting, and that explains also why the pace of innovation during wartime is so much faster, because that cycle of innovation and work, assignment, funding, etc., is so much faster, and the purse strings are held by different people, probably. I mean, the way it's being distributed, right? It isn't congressional funding, let's say. It goes down to the purchasing office of the armed forces, maybe.
Well, it's more of a lot of those capabilities were kind of on the shelf and in development already. It's just that we have more leeway to accelerate them and fund them more quickly, and with that additional funding comes generally, hopefully, faster pace of delivery.
Well, yeah, I mean, you look at the difference between a B-17 and a B-29. Right. Those are just a few years apart. They're very different aircraft. One, as Dan Carlin in his podcast just mentioned, much more like the Cold War style of bomber that we're going to see for the next 50 years, right? So interesting. Okay, well, tell us about your defense contractor role, a little more about what your scope is and whatever you're allowed to talk about, obviously.
Sure, yeah, no, of course. So I have kind of two dominant paths in that. Number one, the bulk of my work is I do the planning for the repair and modernization of 8 different destroyers. The work packages I manage range between $20 million and $80 million. It's typically a 2-year planning cycle and a 1-year execution cycle. So at any given time, I'm wrangling about $240 million worth of requirements. My office on the whole issues about $1.4 billion a year worth of contracts. Oh, I should say funds $1.4 billion a year worth of contracts. The actual issuing authority is a different organization. And so we will pass over them to be the custodians of a pretty significant amount of money. And you see and you learn a lot about competition, especially in the government marketplace, about the value of different services and different types of equipment. It's been really fascinating to see, and I've been around that for a large portion of my career. I've managed a lot of massive programs for the Surface Navy, but really being neck deep in it now, it's certainly been an eye-opening thing. And then the other thing is business development with McKean. There's a few different areas that we're really interested in. Unmanned systems is certainly one of them. And so, government contracting in general is very much a you keep what you kill kind of situation. So a lot of advanced programs is designed to give birth to programs, and whatever you land as somebody working in the advanced program teams, you then go on to lead that program. And continue to develop it and do good things.
Okay, so the hard part is getting people interested in what you're talking about in the first place. You have the credibility to achieve.
You would think that, but there's so much need out there. It's staggering. There's so much opportunity. And even you don't have to necessarily be revolutionary. You can certainly be incremental and evolutionary in your approach of of the value you're trying to bring. And really, it's about can you frame it succinctly? Can you package it economically? And can you deliver? Can you make good on your promises? Right, and if you can demonstrate, if you can put those 3 things together, it's not hard at all to find opportunities. There's some at the level that I work. I work on a couple different 3-star commands, both as a contractor and as Commander Anderson, and there is almost every staff I've dealt with, there's more work to do than they can handle. They're constantly making the decision of what to kind of push to the edge of their plate and deal with whatever the crisis of the day is. And they're always looking for help on how to get out of that mode. And, it's interesting. I was talking with the comptroller's office the other day, and they said, we've kind of shifted our mindset. We'd much rather hire a few contractor positions than generate new government service positions, because we're finding that we're able to get more done that way, and more quickly. So, I don't. My point is, I don't think there's a lot of hard selling that has to be done. I think just some very reasonable conversations and showing that you've got the ability to deliver gets you a really, really long way.
Okay. Well, that was a very insightful answer, and the kind of answer you can only get from, boots on the ground for years, right? So I appreciate that a lot. I guess on the deck in your case there.
Yes,
all right. So let's talk about what you have seen in terms of what government and VCs are looking for in terms of who's going to be making money, who is capable of actually expanding in that. What I'm looking for here is like our audience, some of them are executives at medium-sized companies, some of them are founders at small companies. What kind of process is available to them, and what does that look like from your perspective? What works?
Sure. So here's what I'm consistently finding across both government and VCs is, they want startups to be successful, but they don't want to be the only customer for a startup. They want the startups to kind of show they've got what it takes with that outside of the world of federal funding. And so that leads, almost directly to medium companies that are already established, have got 30, 40 employees who are really doing work right now, and it's very easy to understand how they make money and how they deliver value and who their customers are and why their customers are willing to pay them and will continue to pay them, right? And NASA said that point blank repeatedly, like we're not looking to be a company's only customer anymore, because it creates risks for the company, and it creates risks for the government. At the same time, my impression is that the government is looking to get out of a lot of the sole source relationships that they've had for a long time, especially with some of the legacy primes. There's a lot of pressure, both in terms of overall program, but especially financially, to make some changes and to figure out how to get faster innovation, more value, those kinds of things, and costs are going up, especially for some of our sole sources. So there's some components that we're paying triple the price we were 2 years ago, and we have to, because if you don't have that specific component that's sole source to one provider, you have a failure in a critical mission area, and so as the government customer, we don't have a choice, right? We'd love to have a choice, but we don't. And so there's lots of opportunities like that, and I can't go into huge detail on them, but they're numerous, and they're not hard to find with a little bit of business acumen and business intelligence in terms of digging into what those things are. And what I'm consistently finding, so I watch ship repair contracts get awarded every day, right? And it's conversations that I have every day, and I'm finding this interesting consistency where, if we've got 4 or 5 different shipyards bidding on the same contract, the pricing dynamics change a lot from if I've only got 1 or 2 shipyards bidding pricing on a contract. And that seems obvious and reasonably intuitive when we say it, but when you look across the whole landscape of government contracting, there's so many contracts where there's 1, 2, maybe 3 bids, and that's it. There's a lot of stuff that gets sole sourced. If you dig around on sam.gov, just on the NASA section, dig around for about 2 hours, and what you will find is that you'll quickly find about $40 million worth of contracts that are sole sourced.
Okay.
That's just with only a couple hours of digging, right? And when you read the description of the work being done, I've met and learned a lot of capabilities of different companies in the space industry. I'm like, well, I can find 3 companies that can do that. They don't have to sole source this. So there's a lot out there. SAM is not the easiest tool to use. I've seen plenty of rants about it, and so I get it. I commiserate with those people. But finding sole source is kind of a low-hanging fruit. And then when if you're a medium-sized company and you want to be that prime contractor who carries along a few other small companies, that's how you present yourself. You say, okay, here's the work to be done, or here's what I've seen in the request for proposals. Here's our team, preferably made up of mostly U.S. companies or all U.S. companies if you're dealing with the U.S. government. Here's what each of them brings. And, that same question you have to answer for yourself of, how do I make money now? Why am I a stable partner to work with? You have to answer that for your subs as well. And so if you can present that package nicely, then you're going to win. And we've seen that with a lot of different companies. And it's not just the mediums. Lockheed Martin in particular is a large prime, is really trying to show themselves in that light as somebody who's a champion for smaller businesses, who's willing to quarterback these larger projects and make things come together. And they've tried to distinguish themselves from their competition in that area as well. But VCs looking for the same thing, and they get dozens of pitches a day from a startup that was founded yesterday that's got the next best thing, and they're just not interested.
Yep.
They want a medium-sized established company that is looking to take in some new capital to expand what they're already doing. I think, and you had a guest on before, I can't remember his name right now, who was talking about constantly running into small companies that are looking to execute their exit strategy, and that's not what they're interested in, right? And you just need to sit back a little bit as a business-minded person to understand that, and it's not, it's not esoteric in any way. It's pretty straightforward.
Yeah, it leads to an interesting question that I'm going to have to answer for myself of which season to put this episode in, 2 or 3, because we are talking about investing, but then again, we're also going to be quite technical. So right. if you're a startup founder, a couple of takeaways that you should have from Tim here are, first of all, the funding started 5 years ago or will be there maybe 5 years from now. So don't expect to find a government customer for what you're offering right away. Best thing to do is to go out and get a customer, which I will bang the drum on every day. Go out and find a commercial customer for it. And also, what Tim is saying is if you're a small company, go and find a medium-sized contractor acting as a prime to organize you, right? Organize yourself around and be the fulfillment part of, but also keep looking for other customers, because they're going to have to explain to the end customer, the government, how you are stable as well, and not just depending on this one relationship. So that is very interesting. And I like that you're pointing out, look, if you're a startup, you're not going to make money right away, at least not from this sort of arrangement. You're going to have to go out and find a customer in that. Let's move on then to SpaceX's Starship. Sure. we have this capability. It's come along, and you, with your perspective of looking out, 5 years into the future, the mid-range, how are we going to use this? How are we going to make money? What's it going to drive in that? And it's interesting because Michael Mealing, the VC, has commented on this as well many times, and he does this publicly, so I'm not putting words in his mouth. He's like, I don't know what this capacity is going to be for, like who's going to use it, kind of thing. And so I'm very interested in hearing your answer, because you're going to fill in some of those blanks possibly. So hopefully he'll listen up. So why is Starship important, and what in your view is it going to enable to be done?
Sure. So, I always kind of preface any conversation I have about SpaceX with sort of the idea of, I've gotten everybody to generally agree that it may not be wise to bet on SpaceX, but it's certainly unwise to bet against them. And, so I try to make sure I'm not painting myself as some, rabid SpaceX fanboy who just buys into whatever the narrative is. I really sit down and I examine what's going on with them. So a few different things. So we see lots of content being produced about Starship, and we won't dive into that. But, at a very basic level, there's a couple of things that SpaceX does that are very distinct. One, the user guides that they publish are very easy to get your hands on, tell you a lot about the capabilities and tell you a lot of things that you need to know if you're going to design for using their platform. They're excellent. They're a really great template for any company providing any service. Like, the companies need to push out user guides so people can understand how to use your products. Especially for guys like me, systems engineers, like I need to know I need enough to design with, so I can design systems into your systems and design your systems into my systems. And if I can't find those materials or they're difficult to find, well then, it gets difficult to recommend your product or service to decision makers. But in terms of Starship, so let's look at bare bones, what is that capability? We're looking at probably a minimum of 100 metric tons to LEO inside of a 685 cubic meter volume. The price estimates per launch have been as low as $2 million, but I like to assume about 10 million. Whatever figure Elon puts out, I try and inflate that a healthy amount to give us a better figure. But if you do the quick math on that, fortunately 100 is easy to divide with. Right? So if he is launching at 2 million, he gets there, 20 years from now or 10 years from now if he's in high volume production, you're looking at $20 a kilogram, and a lot of people have talked about that number. Let's say each launch is 10 million, you're looking at $100 a kilogram. But here's the other way you can look at it. If he charges $100 million per launch, that's still $1,000 a kilogram. And that still undercuts the low end of the launch market by about 75%, which is also SpaceX. So he can undercut himself by 75% and still make probably $90 million profit per launch. That's substantial. Yeah. And still while providing a huge amount of lift capacity at a low cost. And so, part of what we really want to get to in discussion is what are the impacts of that, but you got to frame all of that to really understand, like, even if his costs are 50 times what he's advertising, he still undercuts the best in the market by 75%. And that's a really wide margin for error and still being tremendously profitable while delivering a massive amount of value. So it's not something that should be dismissed lightly. I'd love to see that happen for New Glenn as well. Don't have as much information on New Glenn. It's not as easy to dig into what they're doing, and obviously not as public. But so let's talk about kind of where that leads to. So there's a few different variants of Starship that we know of right now or they're being discussed. So you've got near-Earth cargo. There's some talk about near-Earth crude, the tanker variant, suborbital cargo, suborbital crude, cislunar cargo, and orbital debris removal just came out. Mars cargo, Mars crude. I mean, that right there is several different variants, and that by itself is an important point. Extrapolate this out to the idea of SpaceX and Starship being produced like Teslas. Okay. If you're mass producing a vehicle of any kind at a price point that a sizable population can afford it and use it for their own purposes, there's something there. I would not be surprised at all if several years down the pipe, companies are purchasing a Starship for $20, $30, $40 million or leasing it, outfitting it to their own ends and means, and providing their own services. I think that's part of where we're heading here. And so what does that look like, and what can that look like for people? And we'll use a few examples. So, let's just start with the first variant that we talked about. Near Earth LEO GEO cargo. GEO has got a lot of old systems there that need to be updated. There's a lot of debris, floating in pretty premium orbits that can be removed. So that's an important service. And then just updating the infrastructure that we have in GEO that provides services here on Earth. So, to be able to have low cost access to GEO is a big deal. When you get into near Earth crewed, we've got a few different people competing in that. If you're talking about a vehicle that's designed for operating in orbit for 2 to 24 hours, there's a lot of your commercial tourism market right there. And if you look at the net habitable volume studies from NASA, there's a lot of things that you can learn from those. The quick numbers are for up to 2 weeks, kind of the minimum is 19 cubic meters and the ideal is 38. For more than 6 months, the minimum is 25 cubic meters, and generally about double is sort of the luxurious ideal. Well, with those numbers, you're looking at probably 50 people could easily comfortably fit in a visit type scenario variant of Starship and go up there for 2 to 24 hours. And so with those numbers, you're looking at $200,000 per person if you're doing a $10 million launch. $200,000 is a great price point. Then you look at how it's impacting other space tourism companies, right? Virgin Orbit's talking about $250,000 for a 90-minute flight. You've got $200,000. You can strap yourself to a rocket and ride for 90 minutes and pray all your vital organs work when you come back. Or take a smooth ride, hang up there for 10 hours and be able to actually unstrap from your chair, float around, do stuff, come back down. There's some pretty strong arguments made there and pretty strong comparisons. If you get into intermediate, 24 hours to 2 weeks, you can host about 35 people there, based on the net habitable volumes we've discussed. And so that same scenario plays out. But then where it really starts to get interesting is the long duration missions, is 6-month missions, which you can generally host about 13 people using the volumes that we've talked about. So right now, our primary vehicle that we host the primary vehicle that we host 6-month missions on right now is the ISS, right? And I would have to talk with, we'd have to talk to somebody like NanoRacks that really deals in commercial science experiments, things like that, and knows the duration of these experiments to know the real numbers. But if you've got a variant of Starship that deploys up there for 6 months and then does good science, comes back down, you could replace a lot of the functionality of the International Space Station, and probably at a significantly reduced cost. And that's pretty substantial because there's a massive backlog of experiments that people want to get onto the ISS but can't because of time, money, space available, all those things. So you're going to rapidly accelerate the quantity and of throughput of microgravity experiments in a big way, and you're going to do it for a lot less money. So that's important. And there's companies, like I mentioned, NanoRacks, that are perfectly positioned to take advantage of that. If you want to understand how to make money in space, as a commercial enterprise, they're Exhibit A. They're literally a garage startup, and have made their way through and are providing services and carrying up payloads for a huge, diverse international group of customers. So I think that a partnership there is going to be huge, and they know all of the various standardized rack configurations and interface configurations that are already on the ISS that experiments are already designed for. So they could put those same rack systems in a 6-month variant of Starship and just start to kill that backlog in a hurry. So I think they're going to do really well if they get on that. The other interesting thing is, what is the distinction for ISS and Axiom's commercial station after Starship? And I think the distinction is missions longer than 6 months. And so there's an important question to ask there of, okay, how big is that market? And is that going to be enough to sustain this business and sustain their business model? And so there's definitely going to need some examination, because if you have 2, 3 starships that are capable of doing 6-month rotations and they're trading off with each other and they're carrying up 10 to 13 people at a time, that's a big deal. And it's going to have a huge impact compared to 2 or 3 people going up for a significantly higher cost. The entertainment industry is going to be impacted in a big way, right? So we've got Tom Cruise flying up to the ISS here soon, right? And people are pretty jazzed about that. Well, if you can fly an entire camera crew and 6 star actors up there and do a 2-week shoot and come back down at a tenth of the cost of what you were planning on with just Dragon rides up there, that changes things, right? So there's all these different uses for the LEO variants that go up to 6 months. And they're going to have to design those capabilities anyway for the crewed Mars missions, right? Because of the travel time. So those designs are going to happen. The tanker variant is going to happen. We've talked about that. They've already started to look at contracts for suborbital cargo with the military and defense. So I think people can start to examine, is there something big and critical enough that the price points are going to be worth moving things around with that.
Hey, this is Jason Kanigan, the host of the show and the founder of Cold Star Technologies. I want to share with you a new idea. This is very exciting. It's a partnership between myself and another fellow who's a former Marine, a space junkie, a guy who has a lot of experience with like Ogilvy and marketing, and he's also a junior venture capitalist. And some of you may know that I've been a copywriter myself for 25 years and made a lot of money for myself and clients. And so we are partnering up along with a legal team and junior associates. It's very exciting to be able to do something. Here's the exciting part for you, okay? If you're a founder and you're interested in, like, hey, where's the venture capital? We see this a lot, right? You need a bunch of stuff to be able to qualify for venture capital, including like customers. And in order to get there, you need stuff like branding and teams and like a business model and all this stuff. And I find a lot of founders, and you ask yourself this question to tell me the truth, right? Tell yourself the truth. You don't even have to tell anybody else. Do you understand all those things that we just talked about? Or do you just want to build cool stuff? And that is the position where we find a lot of people are in. But look, this project Space Boots that we're looking at here, here's our mission, okay? We're what's called a venture builder. We're seeking to provide venture capital, marketing strategy, and networking for brands, companies, their teams, individuals. Here's the niche, okay? If you're seeking to add value to the 7 space power disciplines as defined by the Chief of Space Operations for the United States Space Force, we want to talk to you. And if you don't know what that is, go to Space Capstone Publications and get the PDF for free. You could buy the hardcover book if you love flipping through catalogs like I do, but the PDF will do, okay? So here's who we're looking for. Pre-seed and seed stage startup companies looking to enter these 7 disciplines, one of them. And we are going to provide the help at this pivotal stage. Most importantly, the storytelling, pitching the big idea. That's what you need help with here, is that positioning, the branding, the storytelling, and that will get you the access. That will get you the stuff you need to get access to that venture capital. We are going to help you craft a winning narrative on this increasingly complex road to funding. We're very excited about this, being able to offer this. It's something that I'd sort of daydreamed about over the last 6 months or so, and suddenly found a partner to be able to fulfill the idea with. If you are in that realm, if you understand what I'm saying and the potential that this is bringing to the table, come talk to us. You can just email me or connect with me on LinkedIn and message me there. Because if you're in one of those disciplines, you should be talking to us about the Space Boots Project, the world's first space tech venture builder for the Allied Space Forces. Super excited. Let's get back to the interview.
With that type of vehicle. The cislunar cargo lander is kind of an interesting situation. You know, as I work in the Lunar Surface Innovation Consortium and as I examine cislunar architectures, you know, there's a lot of discussion about hydrogen versus methane architectures. And where's the value at, where's the money to be made, and how are we going to get things done. And there's trades with both. We haven't really figured out a great way to make a lot of methane on the moon yet. But what is known is that, you know, whoever is landing the biggest vehicles on the moon is going to have the biggest propellant demand, right? And so there's a lot of opportunity to be gained if somebody solves that problem about methane on the moon. Or SpaceX could look at it and say, you know what, for cislunar space, we're going to go with hydrogen. We'll suck up the cost of the boil off, or maybe Lockheed Martin's been digging after hydrogen storage systems for years now, and they've published some really great papers on them. You know, they crack that nut in terms of in-space storage and deal with the power issues associated with active cooling. You know, that's certainly a game changer. So a hydrogen variant of Starship would certainly be a big deal as well. But either way, whether they're running on hydrogen, whether they're running on methane, they're going to be one of the biggest customers for propellant in the cislunar economy, hands down. So that's something that's important. And you know, NASA's already acknowledged it kind of with their recent tipping points awards, and I know you've got other folks like Daniel Faber who get it and understand that reusability is not really fully realized until you have sort of regeneration capability at whatever your destination is. And so if we're really going to drive the cost down and really get our expansion going, you know, cryogenic fluid management is a big deal, and that's why you saw those tipping point awards here recently. And we've got to be able to figure that out. And so there's a lot of opportunity there, and money's already flowing. But, you know, the other thing is, you know, right now, Starship's talking about trying to get 100 metric tons on the moon. Even if they drop down to 25 metric tons and made that trade for being able to get enough delta V to get down and back the moon's gravity well, it's, you know, they need about 5 kilometers per second to get down and back comfortably and safely from a 200 kilometer orbit. 25 metric tons is still way overshadows a lot of the other capabilities out there. You know, so when we talk about, you know, who's trying to land stuff on the moon, you've got Astrobotic, Maston, Intuitive Machines, and Lockheed Martin that are all competing in the 100 kilogram payload range. And Astrobotic's also trying to go for about the 500 kilogram payload range. The next closest at about 1,300 kilograms is the Human Lander System. And so you've got Dynetics and Blue Origin kind of looking at that. And then, you know, Blue Moon, I've seen different numbers out there, and same with Maston Zeus, up to about 4,500 kilograms, so 4.5 metric tons. And that's where it stops. And then the next jump is Starship at 100 metric tons. So even if they came in at 25, they're still going to overshadow the competition by a factor of 4.
Mm-hmm. Okay.
And not have to deal with the waiting around for, you know, being able to produce methane on the surface of the moon. So there's a lot that can happen there, and I'm probably not the only person thinking about that. There's probably people in their own offices that are doing, you know, kind of like the story we talked about last time we talked, where I'd submitted an abstract for the Starship for active orbital debris maneuver back in July of this year, and the announcement just came out.
Mhm.
Right? And I'm sure there was probably somebody in SpaceX's offices in July also thinking about these things. And so that leads us to the next one, actually, is the orbital debris removal system. So like the announcement that came out recently, I initially envisioned sort of a monster of the whale swallowing Pinocchio kind of thing, where the jaw opens up, grabs it, and then maneuvers into a different orbit for disposal. And I batted that idea around with a few engineers, and the biggest thing that came up was exhaust plume impingement. The massive power of the Raptor engines are going to put out a huge exhaust plume. It's going to impact a lot of things. So as I study the problem more, here's kind of what I think is most likely going to happen, is that you're going to end up with kind of a hybrid between the current cargo variant that we see most of the time with the whale mouth and the lunar version of Starship. And the reason I say that is that having that smaller propulsion system that has a much smaller exhaust plume footprint is probably going to be important to dealing with the debris removal problems, because what you don't want to do is keep blasting away your target with your exhaust plume, right? That's what the concern is. They're going to combine that with some out-of-plane maneuvers for their approaches, which is, there's plenty of studies on that show that that's the best way to get things done. And then, I strongly suspect that there will be a couple of robotic arms involved, because that, significantly increases your capture area. And so I kind of envision 2 robotic arms sort of stretching out of the whale's mouth, grabbing the target, pulling it in, and pinning it against a bulkhead or depositing it in some kind of container, depending on what kind of mission they're going after. They're going after the really big stuff. They'll pin it against a bulkhead to keep it from banging around in there. If they're going for several smaller objects, they'll probably try and store them. Another option would be in-orbit servicing. And so, imagine a 3rd or 4th robotic arm in there that's got a line rack of tools, right? So the big arms grab it, hold it in place, or turn it and flip it however needed, and then your other 2 arms are grabbing tools and doing work. There's ample space to support that kind of thing. So, there's all these different ideas. The reason I bring all these different ideas up is I don't suspect that SpaceX is going to want to build every one of these variants. They're probably looking for people to partner with who are already developing these robotic arms and things like that. Relativity Space has got these 3D printing arms. Outpost program from NanoRacks has got a tool changing arm that they're working on. There's plenty of CNC robots that have got tool changing arms. There's a lot of partners who could get involved there and help realize all that, because it's kind of Mars or bust for SpaceX, right? So there's all these other opportunities for these medium-sized companies to jump in and figure out how to do good things. We can continue to move down that, but that's a whole range of applications for Starship that just jump out, immediately. And that's me only putting, 6 hours probably worth of thought into that. If somebody wanted to really nug down and do some studies and figure some things out, even if you just went back to some of the commercial, LEO commercial studies that have been published out there, there's lists and lists and lists of commercial opportunities. And so you figure out, okay, assume I can kit out a Starship for 20 million, and I can launch it for a cost of 10 million per launch. What does that mean for how can I make a business model around that, or how does that change my business? I think the other thing that's in terms of opportunity Starship presents is, being able to get a lot of payloads that are flying now deeper into space, right? So I've had a lot of conversations about lunar mining. And like I said, there's a significant divergence between the space companies that want to get into mining, usually startups that aren't making a lot of money right now. They may be providing some like engineering services or things like that, but their robots aren't actually making money right now.
Mhm.
Most of the ones that I see. I'm not speaking for all of them. Then the other population that I talk to is mining companies who are making money right now doing mining, that are interested in working in space.
Yeah.
And the way those two paradigms go about their business is completely different. And so the hard rock mining guys are saying, hey, look, if we're not going to go 100 meters down and we're not going to drill hundreds, if not thousands of holes and get all sorts of centers down there and cross-hole tomography and all sorts of other stuff going, what are we really talking about here? They're not interested in poking 1 or 2 meters down in the regolith and saying, yep, there's still dirt here. They just have a completely different way of thinking. And so these big payload capacities enable those kinds of architectures for actually finding, what would be categorized as a reserve, that you can actually, make some serious money off of those things and get down to 100, 200 plus meter depths and more. I've seen some fascinating designs that have tremendous capability in terms of getting down hundreds of meters into whatever the target is, and really understanding what's down in there instead of collecting some rocks and some granules on the surface. Not that stuff's not important. I don't want to be dismissive of it. Great science is always great science, and it's always valuable. It's just valuable to different people in different ways. So the other thing, in how you and I got introduced is the CubeSat space. So maybe let's talk about that for a little bit, if you like.
Sure.
Get a quick sip here. So I got involved in CubeSats in 2012. So I've been around that space for quite a while, and I've watched a lot of change. The urban legend is that Dr. Twiggs started it after being sort of frustrated with his students wanting to build bigger satellites and never been able to get things done. And he finally picked up a Beanie Baby box and said, "This is your standard. Get it in this." And that was the birth of the CubeSat Standard, so to speak. I've met Dr. Twiggs a few times. Wonderful, wonderful man. But I've never asked him if that was actually true. So I've got to make it a point to actually ask him. So the CubeSat Standard 1U, which is 100 millimeters cubed, and the max payload, maximum mass is supposed to be about 1.4 kilograms per U, and that scales a little bit. So when you get into your 3Us, I think it's around 4.3 kilograms for a 3U. Here's some things that we know. So the full service pricing for launch, doing all the testing and integration and getting the ride up and getting the launch was in 2013. If you take the pricing that I was seeing in 2013 and you adjust it up to now, a lot of those companies have taken their pricing off their websites. But you're looking at about $80,000 per U for commercial and about $40,000 per U for educational payloads. So if you're looking at a 3U, you're talking about $120,000 to $240,000. So that price point's important. So we know, because it's been done a lot, that commercial companies are willing to pay $240,000 for a 3U launch, and that education is willing to pay $120,000 for a 3U launch. So there's a couple ways you can look at it, and we can examine it from the extremes first. Is the future 10,000 6U CubeSats being launched because the prices have come way down? Well, NASA would have a fit, and so would probably a lot of the space community of having all those little CubeSats out there. Hopefully with shorter mission times, because the cost of launch has come down. They have to keep them up as long to get their demonstrations done or do their science. Or, is the future much bigger standard, say 1 meter cubed, becomes the new standard. We'll call it a KU this conversation, right? Or are KUs becoming, you're going to become the main thing because of the price point has come down to what a 1U used to be. I think the real answer when you talk about any extreme pair of extremes like that is probably somewhere in the middle. But I think that's really worth exploring is, hey, what does it look like when you can launch 1 cubic meter cubes for the same price at which you used to be able to launch 100 millimeter cubes for? That's kind of a big deal. It unleashes a lot of capability. I've designed several CubeSats. I'm kind of a purist. I like to stick to the 3U plus standard. The 6U is super handy as well. But when you have 10 times as much volume and payload capacity, it just opens up so much in terms of demonstration and getting things going. So I think that's important to recognize is there are going to be some changes there. Part of the papers that I'm going to be presenting in March also start to discuss the expansion of the CubeSat standard, kind of going in a different direction. So we've talked about all these different variants of Starship and these space vehicles that can be, either taken up as a payload or incorporated into the Starship itself. I think that there's an opportunity for expanding the CubeSat standard to standardize the hardware in larger space vehicles. So let's take an example. Let's say a CO2 scrubber, right? If you can fit a full CO2 scrubber system in one of these KU forms that we've talked about, 1 meter cubed, and you publish that as the standard and you say, okay, NASA, these 3 big primes and these 3 medium companies are all saying they're interested in vendors designing CO2 scrubbers that are at 1 KU. And here, and you can locate the power connections in one of these corners, and that's what we're going to do. Now you got up to 10 vendors that can compete in that, and if one falls through, we've got 9 others that we're already designing to that standard. Or if one's got better technology, maybe they come along a little bit later, right? Somebody's first across the finish line. They design some really great technology. You get it in your system, it works, but it's kind of expensive and maybe could be more efficient. And the next guy comes along, designed to the same that same compartment size, and he gets 10% more efficiency and 20% less cost. Well, now you pull out the old rack, you slap in the new one, and you go. That kind of standardization is something that I see the industry cry out for a lot. NASA has very poignantly said, hey, we're not going to become a regulatory authority, and we're not going to become a standards producing organization. We're going to do science. But what I have not heard them say is I haven't heard them express an unwillingness to fund the development and publication of those standards. And so I think that's a really interesting conversation that can be had with the Science and Technology Mission Directorates and some of the other folks there at NASA and say, okay, got it. You guys don't want to be in the business of designing, building, and maintaining the standards as far as in-house. But are you interested in continuing in funding them? Kind of like the International Docking Standard, which is another big business opportunity there. That the standard needs a significant update and overhaul. If there's a medium-sized company out there looking for work, so there's all these different things that can change significantly, with the implementation of the Starship program. The other thing that I think is interesting is, so we just saw all the publicity for Sophia, right? And in the background of that is a lot of discussions about whether or not Sophia is going to continue to fly because of the cost of maintaining the program. Well, what happens if you take Sophia off that 747 and you put it into a Starship? And I think it's what people have got to understand is Starship is designed to be the 747 of the space industry. And if you just take that model and expand that out, a lot of the opportunities become obvious really quick. Boeing doesn't operate all the 747s that they build, right? It's United and Delta and FedEx and all these. Those are the ones who operate the aircraft. And interestingly enough, the payload capacity of a 747 is, I believe, I'd have to go check, I want to say 120, 130 metric tons. Conveniently about the same ballpark as what suborbital Starship is designed for. I mean, there's probably a lot of intent behind that. And so people who are asking, what is Starship going to do for the space industry? Well, if you had a 747 for the space industry, Starship is it, and all the things you're doing with the 747 right now, what does that look like for a suborbital or near Earth variant of that capacity? If a 747 could go to space, what would you do with it? Ask that question.
That is brain changing. I think you just said the quote I'm going to pull for the front of the episode about it being the 747 because that is a different perspective. You've changed my perspective in that one instant about who's going to operate these things, right? Because I'd been thinking, SpaceX is going to launch one of these one at a time, and what if you have fleets of them out there operated by different people with different branding and purposes and that? Yeah.
Yeah, absolutely, and I think that's where I think that's where they, over the next 10 years, he's kind of going to have to do that, right, to get the revenue coming in to. So I mean, so let's diverge slightly onto a Mars colony, right? So a Mars colony to be self-sustaining is going to have about 5,000 people, okay. And if you're only able to carry about 20 people at a time, the math works out to a pretty substantial number of Starships. But, and is he ever going to be able to afford that? Well, when you're making $90 million per launch, or you have the option to make $90 million per launch, yeah, that can get funded, right? Or if you're selling off Starships for 20 to 30 million a piece and you're making 80% profit margins on them, and still just slaughtering competition, that's a sustainable business model, right? But yeah, so I'm glad you raised that point. But then the other interesting question is, well, what happens to companies like Firefly, Relativity, and all these others that are trying to target the smaller CubeSats and these smaller payloads in kind of a niche market? I think we're saying, I don't want to see any space company fail. And I hope as many as possible kind of get out of their own way and understand that don't see Starship as a threat, but see it as an opportunity. And to continue to use Relativity and Firefly, they build beautiful spacecraft. They do. They've got these great manufacturing lines that they're putting together. They've got these robotic manufacturing capabilities that, whether you're using them here on Earth or whether you're using them for on-orbit assembly, they're tremendously capable machines. And, instead of, falling on their sword, I hope that they see the opportunities to kit out a Starship or to put a payload in a cargo variant Starship and deploy a 100 metric ton spacecraft in whatever orbit they want to go do work, because they've certainly got the technical capabilities to build those kind of spacecraft, and now they've got the access and the enabler. So I think that's an important point as well. So I've kind of gone all over the place, and fortunately saved your voice a little bit, because I know you got a bit of a tickle there, but. Is there any other topics you'd like to cover or expand on a little bit that you can snip from? I know I just threw up information all over you.
Yeah, we just covered so much. I do want to have you on again. I think we wait a couple weeks or months, something like that, and allow some formation of ideas. But you've already changed my perspective of what could be, which is extremely valuable to me. Hopefully to the audience. I guess one question I have before we go is, SpaceX has always wanted to integrate and keep in-house all of the things, in their manufacturing and that. How do you balance that out or reconcile that with this need that you're pointing out to partner up with companies who have capabilities such as the robotic arms and that kind of thing to combine to create relatively unique product, right, for this use over there. Is SpaceX going to have to change its mind about that and be more comfortable about it, or is some other mental shift going to have to take place?
Yeah, so there's a couple different answers to that. Number one, I don't think we have to change SpaceX's mind, because if they weren't interested in having people integrate and interface with them, you know, as a large payload, then they wouldn't publish such a robust user's guide.
Good point.
I think that they're very interested in having people bring a lot of ideas of what Starship could do, and how they would do it. You know, I think that, you know, apart from launch and recovery, you know, if you're not trying to control the launch and trying to control the recovery, and if you're not doing something that's dangerous for the spacecraft overall, I think SpaceX is going to be very open to people coming with ideas saying, hey, you know what? I want to design this debris removal variant of Starship. You handle the launch and recovery, but, you know, once we get above the Kármán line and into a stable orbit, you know, my operations center takes over and we go do work. I'd be really surprised if they're opposed to that. And so somebody who can scrape together, I think you can do it for under 30 million. Depending on what your fully burdened mandate rate is and how efficient you really are, you may even be able to get it down to like 10 mil for a really like crack team, to kit out a Starship to be able to do that kind of work. And, you know, so long as you're paying for the time, and right, so, you know, their business discussion will be, okay, so I've got a Starship that's maybe underutilized, and I'm launching it once a week, vice, you know, launching it every 4 months, you know, and I get paid to launch, you know, so where's the trade there? I think if people can come through, I think if partner companies and SpaceX can come through those conversations, I think that they're going to be able to find a solution. I think apart from that, so let's get back into, you know, briefly into the space vehicle design. So if you've got a space vehicle that carries propellant that you want to deploy from Starship, right? Those kind of landers are what I've proposed in my papers. You know, I think that, you know, there'll have to be some, you may have to subcontract to SpaceX to design that propellant storage system and that propellant distribution system, simply because it ensures the safety of the overall vehicle, right? And I, you know, if you're a spacecraft designer and you want access, I think you'd probably be willing to make some accommodation there to subcontract SpaceX to let them design the things that they care the most about. And kind of everybody wins there. So I think there's plenty of opportunities for everybody wins relationships to emerge. And I don't really foresee a lot of opposition. And what a lot of people don't know is actually SpaceX subcontracts out a lot of stuff. They don't, a lot of their subs don't, and vendors don't talk about it, but I've personally met subs for SpaceX. And I've observed other subs for SpaceX, especially in the CNC machining space. And so they're definitely open to those parts. They don't do absolutely everything in-house. So those relationships already exist. And I think there's, you know, I think, you know, the reasonable person standard, which may not be the standard anymore nowadays, depending on how you see things, I think will prevail in that kind of situation based on what I've already seen is already happening.
Okay. Yeah, and I know somebody in the composites field who has done subcontract work for them, and they have a very strict grading system for their suppliers. It's hard to get an A, but you know, and that's fine. I love standards. And for folks who don't know, like the aircraft manufacturers have been doing this for a long time. The customer, for example, determines what engine goes on or engines go on the plane. The customer says, I want a Pratt & Whitney or a Rolls-Royce or whatever. It's not the aircraft manufacturer that does that. They make the plane, and they have the specs, and they say, look, you need engines that do this, have this horsepower or whatever to be able to move this vehicle, but they're not going to tell you exactly what you need. So that's cool. And the insurance issues have already been, liability and all that have been taken care of in that marketplace for a long time, and so I'm sure that could be brought across to here, where you've got a main manufacturer of the body of the thing, and then something else being put on it, and then that being used by maybe even a third or a fourth party, right, to achieve something. Well, I think we should finish up there, Tim. That was a lot. This is one of the longer episodes, but I definitely want to have you back on, because I personally know, having talked to you a little bit, we just scratched the surface of stuff that and could talk about. And the more that I get to know you, the better I will be able to focus in on like specific topics and that kind of thing. I think we covered the hell out of the two main ones that I wanted to look at today, so I appreciate that a lot. Where is the best place for people to connect with you if they want to do that?
Yeah, LinkedIn is by far the easiest way to get a hold of me. I work in a setting where I can't have my cell phone very often, which is a mixed blessing, right? It removes the distraction, but it also cuts off communication. But folks are welcome to reach out to me on LinkedIn. Please leave a little note of who you are and why you want to connect, especially if you, not to be rude about it, if you have a foreign last name, I have to be extra cautious. So please, I want to connect with you, but you got let me know who you are and what you're about.
Right. Well, awesome. Commander Timothy Anderson, he goes by his full name if you're Googling that or LinkedIn searching for that. Appreciate you being here. This has been really great. I look forward to you returning.
I had a great time, Jason. Thank you.
Hey, this is Jason Kanigan, the host of the program. Thanks a lot for listening to the Cold Star Project. If you want me to send you new episodes of the Cold Star Project so that you don't have to go hunting around for them or watching YouTube or anything like that, go to this page, coldstartech.com/MSB. That's short for Make Space Boring, which is what we're all about. And drop in your email address there, and I will be able to do that for you. Make Space Boring is another little show that I run. It's a shorter format, quick interviews, and news of the day, and sometimes an update of who I'm meeting and what I'm learning in the space field. It's on the same Cold Star Tech channel. Speaking of which, on the YouTube channel, I can do something I cannot do on the audio-only version, which is add playlists. And so there may be topic area playlists on the YouTube channel that you would be interested in digging into and going down the rabbit hole and learning more about. For example, space law and policy, space situational awareness, the lunar mining and construction and fun stuff like that. So go check that out. That is at coldstartech.com/play. That's the short link to get there. Anyway, thanks